In this video, we will learn how to write some Python code to do some analytics for bivariate data when both the variables are qualitative in nature. So let me show you the data that we will work with. That's the data. So we have 25 orders. So the first column is really not data, it's labels. The second column is category of products that we are selling: appliances, technology, furniture, camping, sporting goods, etc. And the third column, which is really the second data column, is state. Where is the order coming from? So when we have bivariate data when both the variables are qualitative in nature, we cannot really do any plotting because there are no numbers unless we first create some frequencies. So a frequency table between these two variables is called a contingency table. So the first thing we have to do after we read the data is to create a contingency table. And then from that contingency table, we can create some charts. So let's learn how to write some code to do all that. So step one is to read the data file into a pandas data frame. So we'll first import pandas as PD, and then we will read the data frame as pd.read_csv, and then the name of the data file, which is bivariate data qual small.csv. In step 2, we will create the contingency table. Cont table is equal to pandas.crosstab. So crosstab is a function which comes with pandas that can create the contingency table for us. So df, now our variables are called category and state. So category and then comma df state. So let's print this contingency table. So let's run import pandas, works fine. Read the data file, good. Create the contingency table, done. And then print the contingency table. So there's a contingency table by category and states on the other axis. And these are the frequencies, and they add up to 25 because we have 25 total orders. So now that we have the contingency table, we can do a few things. So step 3, create a clustered column chart. So we will have to import matplotlib.pyplot as plt, contingency table .plot kind equal to bar. This is clustered chart, so we will say stacked equal to false, and we can give a fixed size equal to say 10,6, and we can give plt.title clustered column of frequencies by category and state. So let's run these 3 lines of code, and there's our clustered column of frequencies by category and state. So we already have a label on the x-axis. We need a y-axis label. So plt.ylabel frequency. Okay. plt.show. Let's run this again. There. Okay. Now, if you want a stack chart, we can say stacked equal to true. Okay, and let's see. And now we have stack chart. We can also do a heat map. Now for heat map, we need to import a different library, the Seaborn library, as Seaborn. Plot figure, suppose fixed size equal to 8,6. Seaborn dot heat map contingency table, and let's annotate it. So annotate equal to true, and color map, let's put blues there, blues, and we want to format the frequencies as integer, so that D is for integer, and we want to show the color bar equal to true. We want cont table. Okay, so let's run this, import Seaborn, and let's run this. There's a heat map. So Florida furniture has the highest category because it's the darkest. So on the right is your color bar, and these frequencies are the annotations. So once you have the contingency table, you can create a clustered bar chart, a stacked bar chart, and a heat map. Okay. Now, what if you want to switch the two variables around? No problem. Let me change this clustered column chart, stacked, and heat map. Step 4, switch the variables. So what we can do is, so we can copy and paste the code to create the contingency table and switch the variables state and category. And let's run this. So now, last time the categories were appearing here and states were appearing here. Now they've been switched around. So in step 5, we can now create the charts using the new contingency table. So I can copy and paste the code for the 3 charts. So let's run and see how this works. I don't want to import Seaborn again, it's already been imported. Okay. Okay, so there's my heat map. So this time category is here and state is here. Last time we had state at the bottom and category up there. And we have state at the bottom and category as legend. Previously we had category on the x-axis and state in legend. And here we have state on the x-axis and category in legend. Okay. And finally, I will show you how to do a chi-square test. Step 6. Perform a chi-square test of independence. So when we do a chi-square test, we get a p-value, and if the p-value is very small, that means the two variables are not independent of each other. If the p-value is not very small, that is it's greater than 0.05, then the two variables cannot be said to be not independent of each other. So to run the chi-square test, I need to import a function called chi-square underscore contingency from a library called scipy.stats. So when we run this function, we get several output. First we get the chi-square statistic, then we get the p-value, then we get the degree of freedom, then we get the expected frequency table. So chi-square contingency, and we give it the contingency table. And then we can print all of these values, the chi-square statistic, p-value. Okay, so if we run this, there it ran. So the chi-square statistic is 24.73, which is looks high but not that high. The p-value is 0.07, so the p-value is not that small. So based on this p-value, we cannot say that these two variables are not independent. So that p-value suggests that they are independent. Now, if we run all this on a larger data set, the one with 1,000,000 records, medium, then we're going to get a different p-value. Okay, so let's run this whole thing for a bigger data set, medium, which has 1,000,000 records. So we'll run the whole thing. Okay, so the p-value is 0.0, extremely small. So we can say that these two variables are not independent of each other. Look at the frequencies, they're so high, very high frequencies, because they all add up to 1,000,000. So that's my heat map. There's my stacked bar chart or column chart, whatever you want to call it. Oh, I should change the title here. It still says clustered. I should call it stacked. Stacked. Okay, let's run it one more time. All right. There's a heat map, stacked column chart, clustered column chart. Okay, so that's how you do analytics for bivariate data when both the columns are qualitative in nature. So that's the end of this lesson.